Hello everyone, welcome back to my YouTube channel. In the today video, we will discuss about the new concept, that is the empirical and the molecular formula. In this video, we will learn what is the meaning of the empirical formula and the molecular formula. What is the relationship between these two and how we can calculate the empirical and the molecular formula of a compound. So first of all, what is the meaning of the empirical formula? Empirical formula is the formula which gives the simplest whole number ratio of the atoms of the various elements present in one molecule of the compound. So empirical formula क्या होता है कि जो हमें क्या बताता है, the simplest whole number ratio means that it is the simplest formula of a molecule which gives the simple whole number ratio of the atoms of the various elements that are present in the one molecule of a compound. And the molecular formula is the formula which gives the actual number of the atoms of the various elements that are present in one molecule of the compound. सो मॉलिक्यूलर फार्मूला हमें क्या बताता है कि एक्चुअल में कितने नंबर ऑफ एटम्स हैं जो हमारे पास डिफरेंट एलिमेंट्स के दे आर प्रेजेंट इन द वन मॉलिक्यूल ऑफ ए कंपाउंड. सो लेट अस कंसीडर हियर एन एग्जांपल. वी हैव द एग्जांपल ऑफ द बेंजीन मॉलिक्यूल. सो बेंजीन have the molecular formula C6H6, means that the molecular formula tells us about the actual number of atoms, means that in the benzene we have the 6 atoms of the carbon and the 6 atoms of the hydrogen. So this represents the molecular formula of the benzene. If we want to write the empirical formula of the benzene molecule, then we have to convert the number of atoms into the simple whole number ratio. So if we divide the number of atoms of carbon, we have 6, and the number of hydrogen atom we have the 6. So the simplest whole number ratio is, if we divide these number by 6, we get 1:1, means that we have the 1 atom of carbon and 1 atom of hydrogen. So this is the empirical formula of the benzene molecule. Let us consider another example. We have the hydrogen peroxide. So this represents the actual number of the atoms, means that we have the 2 atoms of hydrogen and the 2 atom of oxygen are present in the one molecule of the hydrogen peroxide. So this is the molecular formula of the hydrogen peroxide. But if we want to write the empirical formula of this, then we have to convert the ratio of the atoms into the simple whole number ratio. We have the 2 atoms of hydrogen and we have the 2 atoms of oxygen. So the simplest whole number ratio is 1:1. So therefore the empirical formula for the hydrogen peroxide, that becomes HO. सो बेसिकली हमें यहाँ से क्या पता चला कि जो मॉलिक्यूलर फार्मूला है वो हमें क्या बताता है कि एक्चुअल में कितने नंबर ऑफ एटम्स हैं जो डिफरेंट एलिमेंट्स के प्रेजेंट है एक मॉलिक्यूल के अंदर किसी भी कंपाउंड के. सो जो हमें एक्चुअल नंबर ऑफ एटम्स बताता है वो क्या होता है, मॉलिक्यूलर फार्मूला. और जो हमें सिंपलेस्ट होल नंबर रेशियो बताता है एटम्स का जो प्रेजेंट है उस मॉलिक्यूल के अंदर, सो दैट इज़ द एम्पिरिकल फार्मूला. The next one, we have to find out the relationship between the molecular formula and the empirical formula. यानी कि अगर हमारे पास एम्पिरिकल फार्मूला गिवन है, सो हमें मॉलिक्यूलर फार्मूला कैलकुलेट करना हो तो हम उसको कैसे कैलकुलेट कर सकते हैं. सो दैट कैन बी कैलकुलेटेड ऑन द बेसिस ऑफ दिस फार्मूला. मॉलिक्यूलर फार्मूला कैन बी कैलकुलेटेड फ्रॉम द एम्पिरिकल फार्मूला बाय मल्टीप्लाइंग इट विद एन इंटीजर. हेयर दिस n कैन हैव एनी वैल्यू 1, 2, 3 एंड सो ऑन. The value of the n can be calculated by this formula. Here the n is equal to molecular mass divided by the empirical formula mass. यानी कि हमने क्या किया कि empirical formula हमारे पास है. सो उस फॉर्मूले के बेसिस के ऊपर हम क्या निकाल सकते हैं, उसका empirical formula mass हम निकाल सकते हैं. हमारे पास molecular mass, हमारे पास क्या होता है कि molecular formula भी है कंपाउंड का, तो वहाँ से हम क्या कैलकुलेट कर सकते हैं, उसका molecular mass. सो अगर हम molecular mass को डिवाइड कर देते हैं empirical formula mass से, तो हमारे पास क्या आ जाएगी, n की वैल्यू है जो वो हम कैलकुलेट कर सकते हैं. Next we have how we can determine the empirical formula or the molecular formula of a compound when we have given the percentage composition. Let us consider here a numerical in which we have given an inorganic salt having the percentage composition. Sodium present at 29.11%, sulfur have 40.51 and the oxygen is 30.38%. So we have to calculate the empirical formula of the salt. So in this type of question we have first make a table. In this table we write down the elements which have been given. We have given the sodium, we have given the sulfur and we have given the oxygen. So in the first column we write down the name of the element. Then we have to write out the symbol of the element. So symbol for the sodium we have Na, for the sulfur we have S, and for the oxygen we have O. Now in the third column we have to write down the percentage of the element. Percentage of element we have given 29.11%. 30.11, then we have 40.51, then we have 30.38. In the next, we have to write down the atomic mass of the, then the atomic mass of sodium we have 23, sulfur have the atomic mass 32, and oxygen have the atomic mass 16. In the next column, we have to calculate the moles of the element. And how we can calculate the number of moles? They can be calculated by dividing the percentage composition of the element and their atomic mass. So for the sodium, we have given the percentage composition is 29.11. We can divide it by their atomic mass. Okay. In the next, we have the percentage is 40.51 and the atomic mass is 32. And then we have the 30.38 divided by 16. So these values upon calculation gives, so these gives 1.266, that is also 1.266, and it is 1.897. In the next column, we have to find out the simplest molar ratio. For this, we have to divide the moles of elements by the smaller value of all these three. So the smaller value is 1.266. So in the next column, we divide these values by the smallest number. 1.266 divided by 1.266, this is 1.897 divided by 1.266. So this values comes out to be 1, this is also comes out to be 1, and this is 1.5. Okay, as this ratios comes out to be one of the values in the fraction, so we have to convert it into the simple whole number ratio. So for converting it into the simple whole number ratio, we multiplied these values by 2, so we get 2 ones are 2, here also 2, and this is 3. So this is the simplest whole number ratio of the atoms that are present in this inorganic salt. So therefore the empirical formula of this compound become, we have Na2, we have sulfur 2, and we have oxygen have the 3. So this is the simple whole number ratio of the molecule. So for the determination of the empirical formula of a molecule, first of all we have to draw a table. In the first column we have to write down the elements that are given. Then in the next column write down the symbol of these elements. After that we have to write down the percentage composition of each of the element that we have given in the numerical. Then we have write down the atomic mass of each of the elements that are present. Then we have to calculate the moles of elements. These can be calculated by dividing the percentage composition with the atomic mass of the element. After that we have to convert these moles of elements into the simple ratio. For that we have to divide the moles of element with the smallest of all these. Then we get the molar ratio, and this ratio, if it comes out to be fractional, then we have to convert that ratio into the simple whole number ratio. For this we have to multiply it by 2, and this is the simple whole number ratio of the atoms that are present in the molecule. So therefore the empirical formula of this salt becomes, we have the 2 atom of sodium, 2 atom of sulfur, and we have the 3 atoms of oxygen. This is the, they are present in a simple whole number ratio. So this is the empirical formula of the salt.